Sagittarius, a star. Right now at the center of our own galaxy, something the mass of 4 million suns sits perfectly still. Not burning, not exploding, just waiting. Sagittarius, a star, is the supermassive black hole anchoring the Milky Way, and for decades astronomers assumed it was quietly dormant. Then in 2022, the Event Horizon Telescope collaboration released the first actual image of it, a glowing orange ring of superheated gas with pure darkness at its core. The shocking detail is the silence. For its size, Cygnus A star barely eats. It consumes so little surrounding matter that scientists call it starving. But X-ray flares erupt from its vicinity multiple times per day, and nobody fully agrees on why. The pivot is this: something disturbed it roughly 200 years ago, and the echoes are still rippling through gas clouds nearby. Whatever fed it then left a scar the galaxy is still processing. M87 star. In April 2019, a photograph changed everything. The Event Horizon Telescope stitched together data from 8 observatories across 4 continents and produced the first image of a black hole ever captured. And it was M87. This monster sits 55 million light-years away in the Virgo galaxy cluster and carries the mass of 6.5 billion suns. That is not a typo. The image showed a bright asymmetric ring, brighter on one side because that side of the accretion disk is rotating toward us at near light speed. But the real jaw drop is the jet. M87 star launches a plasma jet roughly 5,000 light-years long directly out of its poles. The mechanism driving that jet is still debated. Magnetic field lines twisted by the spinning black hole are the leading candidate. The cost to anything near it is total. Stars, gas and light itself spiral inward and never return. TON 618. Imagine a quasar so luminous it outshines its entire host galaxy by a factor of thousands. TON 618 is a hyperluminous quasar located about 10.4 billion light-years from Earth, and the black hole powering it has a mass of 66 billion suns. That makes it one of the most massive black holes ever measured. At its event horizon, the radius is roughly 1,300 times the distance from Earth to the Sun. If you replaced our Sun with TON 618, its event horizon would swallow every planet in the solar system and extend far beyond. The accretion disk feeding it glows so intensely that light from it is still reaching us from when the universe was only 3 billion years old. We are not seeing TON 618 as it is, we are seeing it as it was in deep cosmic prehistory, still screaming. Holmberg 15, a star. In a galaxy cluster about 700 million light-years away, astronomers found something that broke their models. Holmberg 15, a star, weighs in at roughly 40 billion solar masses, making it one of the largest directly measured black holes in the known universe. The galaxy hosting it has an unusually faint, diffuse core, a giant smeared-out center with almost no stellar density. The leading explanation is chilling. 2 massive galaxies merged and their central black holes eventually merged too. The gravitational wave recoil from that merger flung stars outward, hollowing the core like a scoop removing the center of a fruit. What remains is a dark, empty cathedral of space with a titan sitting at its heart. The pivot is that this scouring process may be common. Everywhere we see giant elliptical galaxies with depleted cores, a merger and a monster likely came first. NGC 1277. Here is where the rules break. NGC 1277 is a relatively small, compact galaxy in the Perseus cluster, and yet its central black hole may account for 59% of its total bulge mass. Normal galaxies have black holes that represent roughly 0.1% of bulge mass. This one is off the chart. Scientists initially measured the black hole at 17 billion solar masses. Later estimates revised it downward, but even the conservative numbers are staggering. The black hole appears to have stopped growing billions of years ago, while the galaxy around it barely developed. It is a relic, a frozen artifact from the early universe when black holes and galaxies grew in lockstep. Except here, the black hole won the race and the galaxy never caught up. Nobody is sure what stopped the growth. The answer may rewrite how we think about galaxy formation entirely. Holm 15A versus NGC 1277 is not the comparison that matters most, though. Markarian 501. In 1997, astronomers watching this blazer in the constellation Hercules saw something alarming. The object began emitting X-ray and gamma-ray flares so intense and so rapid that the source had to be almost impossibly compact. Markarian 501 is a blazar, meaning its relativistic jet is aimed almost directly at Earth. The black hole driving it is estimated between 1 and 5 billion solar masses. The terrifying part is the variability. Brightness can double in under a day, meaning the emitting region is light days across at most. Energy is being released on human timescales from a region smaller than our solar system. It is the closest violently active blazar to Earth, sitting only about 456 million light-years away. Close enough that its high-energy radiation is detectable without exotic instruments. OJ287. This one has a secret partner. OJ287 is a binary black hole system roughly 3.5 billion light-years away, and it contains two supermassive black holes in orbit around each other. The larger one weighs approximately 18 billion solar masses. The smaller one, about 150 million solar masses, punches through the accretion disk of the larger one roughly every 12 years. Each punch triggers a predictable optical flare bright enough to see with a moderate telescope. Astronomers have used these flares to test general relativity in extreme gravity conditions. The smaller black hole is losing energy to gravitational wave emission and spiraling inward. In roughly 10,000 years, the two will merge. The gravitational wave burst from that merger will be detectable across the observable universe. We already know the countdown is running, Cygnus A. In the 1950s, radio astronomers trying to map the sky kept hitting an impossibly bright source in the constellation Cygnus. It was Cygnus A, a radio galaxy about 760 million light-years away, and it is one of the most powerful radio sources in the entire sky. The black hole at its center drives two colossal jets that terminate in enormous lobes of radio-emitting plasma called hotspots. Each lobe is larger than the Milky Way. The jets are carrying energy equivalent to millions of supernovae per second. In 2017, astronomers detected a secondary source near the core, possibly a second black hole, or a dense star cluster. The original black hole is estimated at roughly 2.5 billion solar masses. Cygnus A was the first object to prove that galaxies could produce energy far beyond anything nuclear physics alone could explain. It pointed directly at the black hole before anyone was ready to believe, Phoenix A. Deep inside the Phoenix cluster, roughly 5.7 billion light-years away, sits a black hole that may be the most massive ever proposed. Estimates range from 10 to 100 billion solar masses depending on the measurement method. The cluster it inhabits is also the most luminous X-ray cluster ever found. The black hole is inflating enormous cavities in the surrounding hot gas, bubbles of radio emission that act like insulation, slowing the cooling of gas that would otherwise rain down and trigger star formation. It is a feedback loop. The black hole eats gas, launches jets, heats the surrounding medium, and prevents more gas from falling in. It regulates its own food supply. The pivot is that this mechanism, called AGN feedback, may be the primary reason some galaxy clusters never produce new stars. A single black hole is controlling the fate of billions of galaxies' worth of gas. 3C273. In 1963, astronomer Martin Schmidt stared at a spectrum from a star-like object and realized the emission lines were redshifted beyond anything seen before. The object was not a star. It was 2.4 billion light-years away and shining with the luminosity of 2 trillion suns. 3C273 was the first quasar ever identified. The black hole at its center carries roughly 886 million solar masses and is actively feeding, producing a visible jet that can be photographed with amateur telescopes. It rewrote cosmology overnight. If something that far away could look that bright, the universe contained engines of unimaginable power. Every quasar discovered after 3C273 confirmed the same truth. The early universe was full of monsters eating at full speed, and we are seeing their light billions of years after the feast. NGC 4889. Inside the Coma cluster, one of the densest galaxy clusters we know, sits NGC 4889, and its central black hole estimated between 10 and 37 billion solar masses. The range is that wide because measuring black hole masses at that scale involves modeling stellar orbits near the core, and the uncertainties compound. What is not uncertain is the environment. The Coma cluster contains thousands of galaxies packed into a relatively small volume, and NGC 4889 sits near the center like a gravitational throne. The black hole is currently dormant. No jets, no bright accretion disk, but the stellar graveyard around it, stars disrupted, orbits scattered, gas hollowed out, tells the story of what it did when it was active. Dormancy does not mean harmless. It means the damage is already done. It's 1101. The largest known galaxy in the observable universe is IC 1101, stretching roughly 6 million light-years across. At its center sits a supermassive black hole, estimated at up to 40 billion solar masses. The galaxy itself is the product of countless mergers, a cannibalized empire built from hundreds of smaller galaxies consumed over billions of years. Each merger likely brought a new black hole, and those black holes merged too, compounding the mass at the center. IC 1101 sits 1.04 billion light-years away in the Able 2029 cluster. It is so large that if it replaced the Milky Way, it would extend past the Andromeda Galaxy and beyond. The black hole at its core is not the biggest ever proposed, but it is the most fitting conclusion to a story about scale. These are not anomalies, they are the architects. Every galaxy with a bulge appears to have a supermassive black hole at its center, and the mass of that black hole correlates tightly with the mass of the galaxy around it. The machine and the structure it built are inseparable. The universe did not form galaxies and then fill them with monsters. It formed them together in a feedback loop that lasted billions of years and is still running. The black holes are not hiding at the centers of galaxies. They are the reason the galaxies exist at all.